I want to talk a little bit today about something I call spatial object programming. And it's basically about programming with objects in space. And I want to start with kind of outlining what programming actually is. So you have some elements, and its core, somehow, programming is actually about making connections. So you have these different functions that you connect to each other, and you create this big logical thing that you call a program. But in its core, programming always is about connecting. And so I'm asking this question: how can every one of us, not just engineers and experts, program the physical, ordinary things that surround us every day? So how can we program or connect these things together? The solution that we use right now, maybe not on this conference, but still everywhere around us, is our apps and the menus of icons and drop-down menus and so on. And then we can have applications that allow us somehow to choose from scopes of connectedness. You can say, here's your living room, and there are 5 objects in the living room, and they all together maybe can do one of 3 choices or so. But that has nothing to do with programming. That has nothing to do with you actually having an idea that you want to put into logic and then put into a space. And on top of that, so I made some screenshots of a couple of these programs that we can use to operate things. It becomes very complex, and pretty much all of these programs do not really enable the ability to connect physical things together. So, and then at its core, I mean, this here is the gold standard of simplicity in the world around us. And it follows a very simple program. It has a light switch and a light, and they're connected. And when you push the light switch, you basically activate that little program, and it will turn the light on or off. It's not a computer in between. It's just a connection, but it's still a program. And so we were experimenting with augmented reality to tap into this idea of spatial object programming and figuring out how we can make simple relations. So here we have it here from my computer. We have a very simple radio. That was one of the first examples that we did 2013. It's too simple for us to be a cool thing, but with an augmented user interface, you can tap on these knobs, and you can operate that radio, and you see the feedback digitally of this radio. That's kind of a beginning part, and then I also can drag and drop MP3 back onto that wheel and reprogram the physical object. And maybe I can fast forward. Oh, we're getting there. But the interesting part that we kind of stumbled on, we just wanted to explore a couple of things that we can do with augmented reality and physical things. And the where's my? The interesting part comes now, because I look at these 2 objects as another speaker, and I can just draw a line from one speaker to another speaker. And that is so intuitive and so powerful when you do it. It's so simple. And none of these applications that I showed before, like this paradigms in our phones, how we connect things together, can come up with such a simple connection between things. It's a very, very simple way. So we further explored that a little bit more. So here you have like the classical teapot, and we have a general purpose knob, and you can connect these things together, and now you can change the property of this teapot. all the time very simple program or connections between different programs. I mean, the teapot itself is a program, and that knob is another program or an object. And here another one. So I can connect from the switch to the light, and I can click it on and off. And so this goes for some time. So here we worked with Audi on a project. We had some knobs, and you could daisy chain connections on your windows. And so once you connect them all together, you can turn the little knob, and it will turn on and off all the daisy chained windows. We implemented this technology in the entire car. You could also go into menus on the screen and take virtual interfaces or virtual functionality and drop it, connect it with physical functionality. So that's an interesting part. This is work that we do for 4 years now, and we've explored in many different directions. But there more and more we prototyped these things and did workshops with companies and so on. We learned that there is a little but very important piece missing. And the question is, how can we actually include logic into these scenarios? Like logic that is not pre-produced, but logic that I can think about and drop it into that augmented world. So how can I build some more complex programs and connections? And so I just first want to show some of the results, and then I want to show you this little demo here so you can see what we came up with. So for example, we were able to build a quite complex robot out of Lego. It's a 6-axis robot. It mimics some of the robotic machines. But this entire robot has been programmed the same way that you've seen before, in addition to the system that I'm going to show you. So it's quite a complex machine to have all of these motors and sensors all programmed and then operated with one hand. And the interesting thing here is also you see a use case of augmented reality that is quite powerful. You know, maybe when you have drones or robots or so on, you have a joystick in your hand with these 2 abstractions of control, and then you have this chaos going on in your mind, how to wrangle the directions and everything. That's the part where operators need to learn and train for 3 years or so on. So this is very simplified with augmented reality. But so recently we made a new nice video, and I want to show you this other example. So, oops, if I would find my mouse here, I just want to show. So here's a little bookmark. And I talked about this bookmark last year. That little bookmark is part of this entire system. And by itself, it has no value. It's a little simple piece. But the cool thing comes when you can connect it with all the things around you, and then also can add this kind of logic system, or we call it logic crafting, into this whole scenario. Because then you can have this, then you can take this bookmark, and we put it here in a scenario. So in the evening, you want to sleep, you put the bookmark in your book, and you close the book, and suddenly your entire home magically starts to react. The lights turn off, the window blinds go down, another light turns off, another window blind, the other blinds turn, and eventually even a thermostat turns to the right temperature. And you might have seen that everything was quite nice curated. And the reason why we could curate it so nicely is because we have a new system in the background that we can place little programs in the space and curate delays, how these things all work, so that everything step by step really follows a nice choreography. So how can we do this kind of choreography? We try to just put a lot of these little notes on everything for every little additional functionality, like a countdown or stress level or whatever. That becomes very cumbersome after some time. we tried another idea that we have this virtual node that you can just drag into systems. You can already build some more complex ideas, like this little story up there. You could model it with a system like that. And again, we built a little Lego example, and here you have a little robot that would try to avoid walls. It has this little program in it. But the problem with a system like this is that it starts to become a little bit crowded after some time. It's really difficult to look at this. So what is the right way? And so this is where I want to show this little demo here. If I get my mouse back, I'm still online. So we have this application. So all of this, what I show here, you can try this out yourself. You can go to a web page that's called realityeditor.org. This is an application that you can download and just test. It works with the Lego blocks, and it works with U-lights in your home. So you can reproduce the scene that I showed you before. And so I'm going to connect the first one, the second one. And now I want to see that I'm in the right network. OK. And you get my screen. OK. OK. So you see what I see. So here we have this little goal. There's like something that can spin and some sensor down here. And here we have a little car. And when I look at the car, I see, OK, there's a motor. Here's a motor, and here's a distance sensor. Here's a button and a light. The button is connected to the light. So when I push here, it's connected. When I click through it, disconnected, and I establish that connection again. So now what I can do, I can connect the button to the motor, and it does do a very odd thing. It doesn't really work. So we need to create some little program that allows the car to move. So let's look at these two things here. So here we have a distance sensor on this side, and we have the motor here. And let's, you see here this little pocket, that virtual pocket. And when I draw from the pocket, there's a square little box that shows up. That's not round anymore. And now I can wire this up. I can go from the button to the square. And then I can go, let's say, from the distance sensor from here to here, and then from here into the motor. So now I have created a little patchwork here, and I can click on this object, and now I get an interface. It's a very simplified kind of grid structure that allows me to arrange a program on that grid. So when I tap on that pocket again, I get a couple of options of little programming blocks that I can drop on here. And the programming block that we need is a seesaw, something that does one with one option and switches back when the second option appears. So this is this here, and I can just drop it in, and I connect these input. When I hold my finger on it, you see through a little bit that this is the program. This is what is underneath. And I connect this like so. Let's see. OK. So I look from above. So I push the button, it drives, and it stops when it hits the second part. And that's what I just programmed in this little interface. And what I also can do, I can drop another of these nodes here. And now I say, I go into that node, and I want to drop a threshold in there, because when I hit that sensor, the goal should circulate. OK, I wire this up and go from the distance into here. Okay. And now, zoop. Oh, you want to see that? Okay, this is a toy. This is a small little program. It's something that I come up with, and I want to put this idea into action, and I can use this for this little toy. But then the same thing has been used in the apartment with the whole curating, that whole space, has been used with the robotic arm to program the robotic arm. That system, you can use that for your industrial environments. We have built a lot of applications. In the car, it would still work because it uses the same system. So from a toy to an Audi car. I told somebody earlier that it's kind of a little bit a rabbit hole that we went down. I'm not quite sure if this is the perfect way, but it leads to a scenario in which you as a user are having powerful tools in your hand to be in charge to curate how the world around you looks like. So basically, you use your own intelligence instead of somebody else's computer with programs intelligence on it to curate how things around you work. And you are not put into a ready, set world that somebody curated for you or systems that has been chosen how to work for you. So the idea here is really to give you a powerful tool in your hand to program the world around you, to do spatial object programming. Okay, that's it. The demo.